So welcome everyone to our panel on Toolchains. So we have a lot of the technical leadership here with Christoph, with Kito, and Jessica, who are both running the API group. Evandro is Christoph's co-chair on Toolchains and Runtimes and has an LVM background. And John is our representative from the HPC community. So he is very active in the HPC field and has been setting up most of the CI environment there. And with our panelists, we're going to go through some of the topics that we already briefly touched on today earlier. And we'll try to get a bit more of a personal touch and an opinion on where RISC-V is going to evolve over the next year, and how we can address some of the challenges. So to start this off, Evandro, we've seen the announcement on vector extensions for LVM lately. I think this went over the lists last week or so, and vector-SIMD is a topic I'm hearing about a lot regarding RISC-V. So on the one hand, it's our biggest extension ever. On the other hand, groups like HPC, but even machine learning are calling heavily for vectors and to have that standardized. I know, Evandro, that you have been very closely involved in the vector enablement for LLVM as part of your job at SiFive. I'm just wondering, could you catch us up on the state of vector support there?
Of course. It'll be my pleasure. So the vector is, of course, a pretty big extension. It has a big number of instructions, and it also brings in some innovations in how, not only because it is scalable, uses scalable vectors, but also the way that it uses it, unlike other tensors. It's much more sophisticated and powerful. Now, we do share with the likes of SVE some limitations really in the compiler infrastructure to support that. So we started first by adding the assembler instructions, then we added intrinsics. We, alongside, we were defining the built-in API for them as well. And then the support for all that and putting all that together. In addition, also a lot of work was done on supporting vector length specific support over the V extension in the compiler. It's a pretty robust effort that required, give or take, a year, and not only SiFive, but also Barcelona Supercomputing Center and CodePlay, among others. And I feel terrible that I don't remember everyone to mention here, but it was quite a concerted effort. So right now what we have is an implementation that's quite usable, especially if you're writing using the built-in API. There is some naive vectorizing that is already going on. Definitely, if you are using fixed length vectors, it actually works fairly well. But there are still some holes in what we could provide in during this time. Namely, the segmented loads and stores is still a matter of that we're revisiting implementation again, because the way the instructions work don't quite jive with what the compiler would expect. Moreover, the VSET-VL, which really provides extra opcode bits on the off-band, like sideband opcode bits to the instructions, which means that virtually every instruction relies on those bits. Virtually every instruction has those bits on the side, lying in a sideband register. And that is a bit complicated to manage efficiently in the compiler. We tried to to remove the unnecessary ones, because it does provide extra bits to the instructions. They can create artificial barriers for compiler optimizations, and that's a pretty big deal. We still see or hope that we can make that better. I think that also the vectorizing for scalable vectors is not something that LVM is quite there yet. Can do a little bit, again, in a naive way. Definitely, vector extensions are more complex than the likes of SVE. Nevertheless, because there are many problems that are common and many solutions that are being proposed that are common to both RISC-V and SVE, we are working together with them. And that's the best part of open source effort, right? Is we are trying to come to a solution that would enable fully the support of scalable vectors in the middle end.
So that said, LVM support is quite new from what I gather. It's just gone in a few weeks ago, or released a few weeks ago. And I'm just wondering, John, I know you've been looking at HPC workloads. Is it too early to tell, or are you already seeing opportunities for vectors? Is this something that the software ecosystem will have to dive in? Or are we already making use of it today?
So we've definitely seen small use cases of it across basic libraries. We do a number of test runs against common libraries from national labs such as Trilinos, and there are candidate loop constructs, both single-dimensional and multi-dimensional loops that will vectorize using the standard GCC and LVM V extensions. Now, there are a tremendous number of use cases that are of significant interest that don't currently vectorize. Some of those may require some hand tuning, possibly some ASMs. Some of those will simply evolve over time with additional compiler support. I think one of the biggest things that I would like to focus on, and I know some of my colleagues in HPC would like to focus on, is rather than focusing on the high-level application workloads, actually look at the various different scientific solver libraries and support libraries, such as SiFive. So that provides a vectorized support for elementary functions. And just spending the time doing the sort of low-level work in the libraries will garner a tremendous amount of performance on a vast array of different application workloads.
So if I understand you correctly, this would be hand optimizing primitive libraries and putting them in rather than auto vectorization.
Yes, yes. And we've seen similar efforts in the early days of SVE, where there were a tremendous number of hand optimized libraries that were forced to optimize sort of orthogonal or non-uniform loop constructs, especially dealing with things like graphs and nonlinear algebra. Those tend to be very, very difficult for compilers to automatically vectorize.
Yeah. I think there's history repeating itself. After all, we've seen that with SVE, but before that, even with advanced SIMD. So yeah, it's always the loop kernels coming first. I guess that's bringing up the question of how we're going to support that with our toolchains, with our libraries and our OS distributions, given that at this point, this will bring in libraries. Some will have vector support, some won't, and they won't be generally binary compatible. Plus, our vector ABI has many, many different options. Kito, I know you're working on the linkers, you're working on ELF and the ABI. Is there a solution on the horizon on how we can handle that mix and match and put it into a single binary distribution?
Yeah, thanks, Philipp. It's a really good question. I think the most ABI challenging for vector is we must compatible with existing API. So I think the only way is extending rather than creating new API there. Otherwise, could you imagine we need, for example, we need two Fedora, one for vector and one for non-vector. It would be very crazy. But in fact, most people just want the one Linux here, and it could be run on vector and without the vector. So, however, when we start to study the vector calling convention, we found the vector it's really hard to add in the vector calling convention without break any backward compatibility. If we consider the dynamic linking and especially for the something about the lazy binding, it's kind of optimization during the dynamic linking. And now we have a proposal from SiFive now, which can extend the API with the minimal impact on the backward compatibility there. So I believe we could have a solution this year for the vector calling convention and the API stuff this year. Yeah, if the vector has ratified this year. Yeah.
Yeah, I guess there's higher powers at work for the ratification, and we can all just light a candle and hope that this goes through. But I'm having my hopes up. But since you mentioned there are solutions in place, and this is coming up almost weekly or bi-weekly, all the new extensions, EBI support. And I know that you, Jessica, have been diving deep into that. So not just vectors, but bitmanip and everything else. I think you are our native expert on the ELF header and how to use those extra bits. Do you want to add on to what Kito just said and lead us forward there?
Yeah, sure. So more generally, as well as vector, as you say, we have all these other extensions on the horizon, hopefully some of them as well being ratified towards the end of this year and others surely coming next year as well. And as we said, we have this great desire to ensure we keep backwards compatibility because we want to keep supporting existing hardware. We don't want to have this explosion of different combinations of builds that you have to download and run. We just want one build that everyone can work with. So the first issue is just making sure that your hardware has all the instructions that the binary expects and making sure that you can't construct binaries that can never run. So for example, you can't mix floating point code with floating point integer register code because the two extensions aren't compatible. So for that, one of the things we've done is we've made sure that every single binary gets embedded in it, the full list of extensions that it expects. That allows you at link time to verify and unify everything. That allows you at load time to verify that, yes, this binary is going to work. And if not, it's going to be able to bail out and give you a nice user-friendly error rather than attempting to run and either crashing or giving corrupt results. So that's been sort of the first major issue, and that's applicable to any extension that's coming up. Then we have extensions like Vector, which, as Kito says, introduces additional complexity because it's one of the few ones that adds additional architectural state that's visible to the user and to the ABI. And so for that, we've been inspired heavily by the solution that ARM adopted for their SVE to ensure that in these special edge cases that the dynamic linker does not trample over the arguments and that we can ensure everything manages to interoperate correctly. I think Vector is pretty much unique in that respect. Some other extensions have reasons to want a slightly different ABI. There are discussions as to whether that's necessary or not. Our general belief is that the fewer ABIs we can get away with, the better. And so there is pushback on micro-optimizing for specific use cases. However, at the same time, it may be that, say, in an embedded environment, something like code size becomes more important and you're willing to pay that extra cost of taking on an extra ABI because you control everything that you're compiling for. So that is the delicate balance we're trying to meet at the moment. It's trying to minimize as much as possible, but we are open to additional ABIs as they become necessary.
I mean, I must admit, you really had me there when it came to the user-friendly error messages. I was fighting a bit with consumer websites the last couple of days, and to keep it in the spirit of user-friendly error messages.
As user-friendly as a RISC-V architecture string ever is.
And no, it would probably say, this binary is not being executed for your own best, and would just move on. But yeah, but actually, since you're saying architecture string, you're touching on a very good topic. So we're having all those new architectures. There's even a discussion tomorrow on the GCC meeting regarding relaxing some of the restrictions. We're seeing a lot of demands to get them up early. And have experimental versions. This is going to affect the way that we're handling branches, for example, on the upstream tool chains, on the assembler, on the compiler, throughout the entire toolchain. Kito, you've drawn up that proposal. I know I think you'll be presenting it tomorrow again. So where do we stand, and how difficult is it to have all of those new extensions supported in a single toolchain?
Yeah, thanks, Philipp. I think many people are interested on this, and maybe I guess some of you may know the GNU toolchain has a very, very strict policy for unratified extension on upstream. And basically, GNU toolchain only accepts the frozen or ratified extension to the upstream. And all other unratified extensions are working on the RISC-V GitHub repo and a few other repos. And we are trying to keep one development extension, one branch per extension. And it worked well before because there was only few extensions before. But however, in the last 2 years, we have a lot of extensions are proposed very quickly in this 2 years. We are facing some issue on this model. First is the copyright issue. It's a very serious issue. Yeah, on GitHub, it's really hard to track who has signed the FS copyright assignment or not, because GitHub is based on the GitHub ID rather than the email. So it would be really serious issue when we try to submit a patch to upstream in future. In fact, we are really got some trouble on this issue before. The copyright issue means corrupts some of the implementation, so that we must re-implement the whole stuff again. Yeah, and maybe some of you know, the GCC has released the copyright assignment in the last 2 days.
Yeah, just last week.
Yeah, but it's just for GCC bin utility, and other GNU toolchain part still has such policy. So basically, it's still a big issue here. And the second issue here is one developer branch per extension policy. It caused a huge merge effort when we want to evaluate multiple extensions at the same time. For example, if we want to evaluate vector and the beta manipulation extension, oh, sorry, you need to handle the very complicated merge issue first. I already handled this once for our internal toolchain. It's really, really complicated and time consuming. Yeah. And third, some party and the developers are not comfortable working on GitHub for several reasons. Yeah, I just don't list the reason, but I know I got several feedback about this. Yeah. So that we started a discussion with the community since last year, to come up with a policy that most people agree with. Okay, there is the new policy. First, it's the master branch still apply the same rule. What does it mean? It's we still apply, we still only accept the frozen or ratified extension for master branch. But we will create 2 extra branch there, integration branch and the experimental branch. Integration branch for release the draft and experimental branch for working draft. And let me explain what's different. Release the draft means it has been released with a version like vector 0.10, but like the vector 1.0, it's still a set changes. So vector 1.0 is a working draft. So vector 0.10 is okay for integration branch, but 1.0 is not okay for integration branch. And it's okay for experimental branch. And I think the main benefit is we can reduce the extra development effort, like the merge different branch for multiple extension, because they will all in the same branch there. And then remove the duplicate effort on submit the page, one for GitHub and one for upstream again. Okay, we can remove the duplicate. And the most important thing is this policy could make most people happy. Yeah. Although I still prefer the review on the GitHub is more convenient to me. Yeah. So I expect this policy change can get more development energy on the RISC-V Toolchain part and provide a more stable implementation for evaluating those experimental extensions. Thanks.
That sounds great. Hopefully gets us also a bit closer to how LVM is handling that with the experimental ones. And I know that Christoph, you've been working recently on string functions, you told me. Also, bitmanip is going to show up in that context of string functions soon. So you probably have seen firsthand recently how this may work and what the upcoming challenges will be.
So I think we all are very happy when bitmanip or also vectors are finally over the finish line, because we all expect, especially for bitmanip, that processors that implement these extensions and instructions, they will see a huge performance improvement all over the software ecosystem. You mentioned it, the string functions, or let's be more particular, let's say a string comparison. We have analyzed this and we have seen that this string compare or string n compare benefit a lot from having instructions like argb, which simply allows a lot more parallelism per loop iteration. So in the end, we will end up with much less instructions per loop, or in this case per character, if you calculate it like this. And I think we were somewhere near 6 or 7 cycles per loop iteration per word, which is quite an improvement to what we are seeing at the moment.
I could say, and it's going to translate into better Drystone scores.
Yes, this as well. But I think it's not only Drystone or other benchmarks. It's also like things like managed runtimes, which often use glibc implementations, and they will benefit as well. Maybe something what is related to that is how we are going to handle that in real life. So is my Fedora going to support this? And if yes, how? I think what we should mention here is the mechanism which is called indirect functions, which allows to implement something like string compare in several versions, for example, one with and one without bitmanip instructions, and let the dynamic linker resolve this. So pick the right one for your target architecture, and so you will get a binary which is ready for your SoC with and without these bitmanip instructions.
So John already made the mistake of nodding at the wrong spot there. So actually I have a follow-up for him at that point, because Christoph said we'll have multiple functions, and John, you beat us all to having a CI. and the testing infrastructure. I still don't understand how the HPC people could have that in place before anybody else had it, but you've done it. I guess you're also compiling for different ABIs then, or not ABIs, different extensions. And that must be an interesting experience, plus having those functions with those ifuncs, indirect functions, where you have multiple types if you're running a CI. So did you encounter that? How is that affecting HPC? What's going to happen there? Okay,
so I'll start off with a rather selfish plug. So we do have what we call the RISC-V test.org set up and running. It's a publicly available CI suite. It's running Jenkins, which Jenkins is not beautiful, but it works. We are hosting a set of test and development resources that run weekly tests using a pathological set of libraries and workloads. And while these are not performance-related tests, these are really compatibility tests for the various different versions of GCC and LLVM. So can I actually compile a set of applications with a set of libraries and a set of runtimes using the target toolchain for a target architectural variation with a target ABI variation? So we have this up and running. We have several different versions of LLVM running in the CI suite, several different versions of GCC, and we also pull LLVM and GCC master. So we are getting the latest and greatest that comes out every week in terms of the source code. What's very interesting about this is there are significant variations between GCC and LLVM with respect to supporting different architectural combinations of ABIs and specific architecture extensions. So GCC is by far the most stable, but we actually see some very interesting instruction variants with LLVM. There are some libraries that only compile with LLVM, but do not compile with GCC. There are other libraries and other tools that will only compile with GCC or the GNU suite because there is a G4tran variant, and all of us old HPC people really care about Dusty Deck, Fortran 77 and Fortran 90 codes, and we simply don't have a stable enough FLang compiler and FLang front end for LLVM to compile any sort of demonstrable Fortran codes at this point. So what I encourage people to do is go look at the set of tests that we have and the set of workloads that we are using. If you would like to contribute, there is a GitHub page that's linked off of the CI suite, and I can post it in the chat here in a bit. We basically drive everything with a set of well-defined shell scripts. So if you have applications and you have libraries that you would like to see tested, then either reach out via GitHub and submit an issue, or simply pull the script database and submit a PR with a new script. And we're more than happy to run everything publicly. We have a few restrictions in that we can't run proprietary code or code that has been labeled specifically export controlled because we do want to behave in a good manner with respect to the RISC-V Foundation. So we are more than happy to collaborate with everyone out there if there's applications that you'd like to see run.
That's actually leading up to my follow-up question. So actually it's Mark's question he put in Q&A. Do we have a list of libraries that would need to be customized for RISC-V extensions for HPC? Or what I wanted to originally ask is, what do we need to do to make RISC-V really the or one of the best platforms for HPC?
So with respect to HPC, you always have to start out with the basic level solvers. So your dense linear algebra solvers, BLAS, LAPACK, LinPack, and ScalaPack, they all have to build and run. Once we have those sort of those bounce points, we can start building up larger solver suites, such as Trilinos. That is by far the largest one that we use. There are several others generally developed by the DOE labs and the offshoot academic organizations. Most of them are dense linear algebra or sparse linear algebra solvers. There are some adaptive mesh refinement codes that we would like to see run, and we would like to specifically port those. And then there are a set of sort of emerging libraries that are used in both scientific computing and sort of the industrial side of scientific computing based upon graph laws. So these are using sparse linear algebra to solve large-scale graph problems across a whole supercomputing platform. So this is sort of the basic candidate set of libraries that we would like to support, and the various different libraries that are required to support those, such as HDF5, SiFive, the various different IO libraries. And that's where we actually see the biggest gap in supporting RISC-V for HPC is we have yet to be able to actually successfully build things like OpenUCX and drivers such as the InfiniBand stack for a RISC-V platform. Even though we have PCI Express support, we can't quite get the drivers compiled and stable enough to have high performance interconnects, high performance file systems, all the system and platform level things that sort of need to be shaken out before we can actually build a demonstrable machine.
That actually sounds quite exciting, given the fact that once you've done that, you probably run into the toolchain issues again. So
yes,
you have the toolchain issues up front, then you need to stabilize the system, and then you run into the toolchain and runtime issues again, as you can actually take the applications on there. That said, and just watching the time a bit, one last question to you, Christoph, before we jump into Q&A with the audience, and that is basically HPC is the tip of the iceberg here, or one could also say HPC is the iceberg, and everything else we've seen is just the tip. So we would like to optimize for everyone, and it's not just HPC. So what is on your roadmap? What's in your vision and also in Evandro's vision when it comes to getting us ready for all of these applications? Not just HPC, but banking, machine learning, everything we've heard about today.
You already mentioned we see quite some momentum in the area of managed runtimes, machine learnings, HPC, like John just mentioned. And I'm pretty sure these areas will continue to bring good news in the next month. Additionally to that, I think there will be significant changes and optimizations with respect to code size and code speed. One thing, of course, is the upcoming extensions. So vector and bitmanip will have a major impact there and a lot of changes. But also, I think that the availability of hardware is going to improve. So there were a lot of chip shortages recently, but more and more boards are now shipping and available to the community or to a wider community. And I would expect that a lot of additional developers will get their hands on RISC-V and will also work on various areas. Again, code speed and code size will be what I would expect major targets. I don't know, Evandro, do you want to add something to that?
Yeah, I would say that there is a lot of work definitely on the front of enablement of all the new extensions coming along. I think that has been mostly what we have done so far. But yes, looking forward, we're looking more at application-specific solutions and enablement. Now, we at RISC-V International and we as the community, we don't push, we encourage. But it comes from the RISC-V developers, really. I think that the great thing that we provide is a forum of collaboration. This ISA, I think, brings something new, not only to how hardware is designed and commercialized, but also how software is designed. I think that doesn't have to be open source for anything to be collaborated in these forums. But I think that they provide a great opportunity for engaging with other companies and institutions, so that at the end of the day, something gets out better and quicker.
Maybe also a call to everyone in the audience to join the community.
Yeah, that's absolutely the hope. So RISC-V lives from everybody donating their time and making solutions better. So all of our software ecosystem basically is open source. And I've known Christoph for 15 years now. He is hoping that with all those things coming in, we'll have good news. I'm more afraid that with all these things coming in, there will be lots of new issues, lots of new to-dos, and that means we really need all hands on board and as many contributors from the audience and from the ecosystem as we can get the RISC-V system better and the software better. So let's jump to audience. So I have one here. I think, John, you already responded to that on chat. So we do have, yes, the RISC-V test org site with publicly available. The URL is in the chat, and generally speaking, we're working. A few groups within RISC-V are working to improve the way that we do CI and CD. So it's not just toolchains and runtimes; it's HPC. And there is another group coming up under the ISA infrastructure that is also going to have CI/CD related mission, so that we hopefully at some point have one central infrastructure and collect data for everyone. So I know we've gone over time. I hope we aren't keeping too many people off going to work. Or I also hope that not too many people have already dropped off because they wanted to go home. So please post your questions. Otherwise, Kim, I see you. Do you have a question to me?
I do not. Well, I do have a question to you. So when we finish this up, we are going to be, we're going to lose the Q&A. So where should people email questions if they want to get involved, or if they have questions? Where should they send emails? Do you have a place, Philip, or should I have them go to either help@risc-v.org or info@risc-v.org?
I would say help.risc-v.org is always right, because Stefano and Jeff are doing a great job in redirecting people. But generally, if the topics are toolchains and runtimes related, go to Tech Toolchain Runtime, which is put into the list. So it's one of the groups. And there are some closely related groups, but given that this is the Toolchains and Runtimes forum, please first go to Tech Toolchain Runtime. And that group, which means probably Christoph and Evandro are going to catch it if nobody else does it, are going to redirect you to the right other groups. So we're all talking to each other, and eventually your request ends up in the right mailbox.
Perfect.
I've put that email address in the chat.
Okay. Anybody who's still on there, go ahead and grab it. And you can always find it as well by going to risc-v.org and hitting the working groups directory button at the top right of the page, and then going to any of the working groups and get information. So thank you. Do you all have anything else before we close it out?
No, thanks, Philip, for hosting the panel.
Thanks, John. It was a pleasure having you on. Given that HPC and Toolchains and Runtimes has not really been talking as much as we could have, given that we were all busy, we were all busy doing our own work. So it was a pleasure having you on. All right.
Yes. Well, thank
Kim,
you all.
I guess closing remarks are yours.
Closing remarks are mine. Well, thank you. Thank you for all of you. I saw many of your comments answering the questions in the Q&A. Thank you. Thank you for everybody who attended. And reminder, we have a call for papers for embedded technologies that closes on July 11th, which I believe is a week from Friday. So if you want to participate in our next forum and present, make sure you submit a CFP, and then also watch for the CFP for RISC-V Summit will be opening. We're hoping sometime soon is all I can promise. So thank you all.
Thanks, Kim.
Thanks. Bye.
Thanks, everyone. And have a good work day or a good night, depending on where you live. Bye.